Okay, so here we're going to take a look at some related statements. All right, so in the previous video we talked about implication, plea implies Q. All right, so we're going to take a look at, so here again, this is implication. Statements that are related to the implication. Right, so if we have a statement P, a statement Q, the implication if P then Q or P implies Q, we are going to define the converse of the statement to be Q implies P. We'll define the contrapositive to be the statement not Q implies not P. All right, and then the inverse will be not P implies not Q. All right, so for instance, let's say here if the bus is late, then the meeting will start without me. So that is our implication, right? So P is a statement, the bus is late. Q is the meeting will start without me. All right, now in terms of the converse, so let's go through. All right, the converse would be if the meeting starts without me, then the bus is late. All right, so now let's take a look at the contrapositive. All right, so we negate Q here. So the meeting starts without me. The meeting does not, if the meeting does not start without me, then the bus is not late. Okay. All right. And then the inverse of said statement would be, here, let's see here. So not P. So the bus is not late. If the bus is not late, then the meeting does not start without me. All right, so here's an example of a statement, an implication, right? And then what the converse, the contrapositive, and the inverse look like. All right, now in terms of our quantifier notation, right? So just using quantifiers here, the way we'd express an implication, right? So quantifiers, so our implication would look like this, right? For all x, P of x implies Q of x. All right. And then our converse, like for all x, q of x implies p of x. And then our contrapositive, for all x, not q of x implies not p of x. And for my inverse, for all x, not p of x implies not q of x. All right. Okay. All right. So let's go over one more example here. So let's say the implication was if you order dessert, then you pay extra. Okay. Okay. So this is our statement here, our implication. All right. So P would be the statement you order dessert. And then Q would be the statement you pay extra. Okay, so first let's take a look at the converse. So that's Q implies P. So it says if you pay extra, then you order dessert. All right, now the contrapositive states not Q implies not P. So this states if you did not pay extra, then you did not order dessert. All right, and then finally the inverse. That states you did not order dessert. If you did not order dessert, then you did not pay extra. Okay, so here, a couple things here now. You might be asking yourself, right, if the implication is true, does that mean these other statements are true? Well, as it turns out, for the converse and the inverse, not necessarily, right? Because if we think of the converse, right, if the implication is if you pay extra, then you order dessert, so the promise is that you paid extra. So let's say that is met. I mean, that doesn't necessarily mean that you ordered dessert, right? Maybe you had a drink, right? Maybe you ordered an extra drink, something like that. Okay? Now, the contrapositive if you did not pay extra, then you did not order dessert. Right? Now that is actually true in all cases, right? And what happens here is that the contrapositive actually is always true, right? If the implication is true. All right. So, and if we see the inverse, if you did not order dessert, then you did not pay extra. Again, also, right? That may be true, right? But it also may not be true. Maybe you ordered something else, right? But the contrapositive, that will always be true if this is true, right? So here, if P implies Q is true, then not Q implies not P. That will also be true. All right, so now let's see why that has to be the case here. All right, so let's take a look at our truth table here for the implication. All right, so not Q, not P, and then not Q implies not P. All right, and let's see, the different truth values are these, right? False, false, and then false, true. All right, so these are all the different possibilities, right? And from our previous truth table, right, the only time that this one is false here, so is when the promise is kept, so when Q is true, but the implication is not, is false, right? So that's false here. Everything else is true. All right, so now let's take a look at QP. Oh, excuse me. P, Q, and then P implies Q. All right. So let's take a look here, right? So if we look at P and Q, right? So in this case, not P is true, so P would be false, and then not Q is true, so Q would be false. Okay? Now in this case, this implication is true, right? Again, the promise was not kept, so the hypothesis was not met, so the conclusion really doesn't matter. So now let's take a look at the next one here, right? For P, if not P is false, then P is true. And if not P is true, not Q is true, then Q is false. Okay, well, this implication is also false here, right? Since our hypothesis was met, but the conclusion was not, so that makes the implication false. Now, in this case here, not Q and not P are both false. That means P and Q are true. Well, this implication is true, right? And then lastly here, if not P is true, P being false, and again, really that doesn't matter, that's going to make this true, but in this case here, not Q is true. All right, but the implication is still a valid statement. All right, so we could see here that in all cases, right, the contrapositive is equivalent, right, to the implication P implies Q.